Hey guys, welcome back to the Python BACnet Stacks Playground. So we're studying applications for using the BACnet Stacks BAC0 and BAC pipes for HVAC controls technicians and IoT practitioners. Once again, it's not an advanced networking course, nor is it a deep dive into the low-level BACnet protocol bytes on the wire level. It's just Python-based applications that an HVAC control technician would run into, or an IoT, and any data types will be just everything is converted to Python data types under the hood. Okay, so we're working on the VibeCode app checkpoint 2 using BAC0. So yesterday we created, let me pull that up. So we're still in the process of doing our VibeCode checkpoint app. Let's get into VS Code here. So this was yesterday. So we're on a BACnet read multiple, just from the devices on my test bench, and then we'll end up putting in. So this was the fake VAV box with the VAV fake points, and then we'll add to the air handling unit device. This is the other, these are just fake devices running on Raspberry Pis, which I demonstrated where to find those Python scripts if you want to practice running a fake building automation device. I have those because I don't have access to a live building automation system. So we'll be working on this, but I think today will just be just a little bit of a deep dive into our just the theory part of the lectures. So maybe we'll get a little bit more into the as that progresses. Okay, so just getting situated here. Let me just get this put back together. So okay, so we're on day 9. Let's just do some theory today, and then maybe tomorrow we'll work again on the VibeCode app checkpoint, just to work on it a little bit every day. And then this is week 2 to 3. We'll have a full-blown BACnet read multiple, save the data to a CSV file, and then rotate the logs once per day using the Python's built-in CSV library. And then we'll just VibeCode some kind of daily rotation mechanism, which there's Python libraries for that, but we'll just let AI come up with the best practice for that. Okay, so I'm going to close that, and then let's get into day 9, conditions and while loops. So the flow of your program using if, elif, else statements, and then there's also while loops, and you'll also be using break and continue. Everyone's probably pretty familiar with if, elif, else statements. So here, if the temperature is less than 60, print I'm too cold, or if the temperature is greater than or equal to 60 or less than, you're in your temper range. So I think building automation technicians would definitely understand that. And then a while loop is just do something continuously while some condition is true. So while the count is less than 5, increment the count by 1, and then when this count gets above 5, this breaks. And then this is just another while true, which you could set as another break condition. So it's entering in if Q is pressed on the input function, break out of the while true loop. I've also used this in scripts where if the fan status is true, so like while fan status equals true, you could be doing things in here, else, it's false. And then this is the range loop that we've talked about. So this is using the continue operator. So if the number is divisible by 2 with the modulo operator, skip. Continue, I think, would just skip the print right here. So here's some examples. Fibonacci sequence, which I'm not going to get into that because I think it's super confusing. Okay, so let's try and pound out some micro exercises and then call it a day for this one. So I'm just going to put these up here. So this would be write a program that inputs the user, write a program that prompts the user for a number and prints whether the number is negative or positive. So I might just actually copy this. This is the BACnet priority array example, which I think is a nice way. I'm just going to use this directly. So we could even say add in another elif here and just say if the priority equals 8, that is the building operator's priority. So I'm just going to say, maybe I'll just do this. This is the building operator's priority. And then we're just going to say maybe we could say, I might even just say this. It should be if the priority is less than or equal to 7. This is, I guess, automatic high priority, manual life safety, building operator's priority, and then this is like where the supervisory level logic writes, supervisory level priority. So like this exercise is just about like using this input function, doing some if elif else, and then also some operators if the number is greater than or equal to. But in BACnet, we could actually study this a little bit. So we've been working with this tool quite a bit, and then I'll just pull up a device on the test bench. So this is the fake devices right here. I'm just going to drill into the fake ear healing unit. So like this is just made up data for the priority array in BACnet. So a writable point in BACnet has a priority array, which is actually a property that we could request from a point. So if we went to this analog input, it doesn't have a priority array. So it just has one value, and you cannot write to it. No priority array. If we went to our vibe code app 1, like you can actually request right here instead of present value, you could type in priority-array, which we'll get into later, but that's what that kind of represents. And if a point doesn't have a priority array, that means it's a read-only, when typically anything that's an analog input, binary input, anything that's like an input would be typically a read-only point. And then a point that is set up for to be writable has a feature called priority array. So if we look at our fake supply fan output, SF-O, this automatically pops up because the device is supporting that, and the write feature is not grayed out. So if I click on our BACnet scan tool priority array, that is our 16 priorities. And what this was trying to say here is the building operator in building automation defined by BACnet, their data comes through at priority 8. So if a building operator was making overrides to a building automation HVAC system through the controls graphical user interface, let's say they're changing a set point or they need to override something because the logic isn't working, it would show up here in the point priority, but anything above this is a higher priority. The number is smaller, but that means they have a higher priority. And then they're saying priority 1 is life safety designated. And then this is high priority, 2 through 7, I guess. So if you had like a really complicated building where they designed, let's say, an elaborate smoke sequencing, some kind of really important fan control or something that if the fire alarm goes off, they need smoke purging, something to happen, they might even say to put that on a higher priority than what the building operator can write. So they would put the logic here, up here, and then anything below, the building operator can write over it. So that so if we're writing, so typically like below 9 through 16 is where the building automation supervisory level logic writes. Let's say we're sharing outside air temperature data across the network, or the supervisory controller is writing a schedule occupying air handling unit to run. It could come in down here somewhere, and then somewhere in this lower range optimization we also do down here too, where if we're optimizing in Python scripts outside of the BAS or on the BAS itself, like we'll be down here 9 through 16 somewhere, where then if the building operator needs to override it because the optimization is causing problems in the building, the priority 8 will be able to override anything down here. So hopefully that makes sense. So this is how that works in the real BACnet application. And then in our little theory lecture here, we do Python script lesson. What happened? Something happened. I'm just going to clear that. Type in clear. Python script lesson. Okay, so enter a priority. Comes through as manual life safety. Then if we do enter a priority 8, this is the building operator's priority. Pretty simple little program. Priority 15, this is supervisory level priority. So it's like using this control structure here, the if elif else. I think we did enough with that. Hopefully that makes sense about the BACnet. That's a really important thing to be able to know. If elif else. And then, all right, so then I did actually just copy this right into a note right on the program. So I might just say, yeah, we're down here. Use a while loop to compute the sum of numbers from 1 to n. Prompt the user. Okay, so I might just call this num. Enter a number. So this is going to input from the program like we did down here and convert it to a float. And then there's also just like a few things. So we could do like, I think we could do total sum equals 0, and then just like current num equals 1. So use a while loop. And then we could just say something like while current num, let's see, so we would want to say less than or equal to num. We would want to total sum plus equals current number, and then current number, we want to increment that as well, so that would be plus equals 1. And then we should just be able to print the total sum at the end. Let's try 20. Okay, so I think that works. So what that's doing is it's adding each number to the total sum plus the current number 20 times. We could even add in a print total sum right here too and see what that looks like. Do 20 again, and this is how it increments all the way up to 210. Kind of fun. Okay, so enough with that. write a loop that prints the squares of numbers 1 through 10, but skips squares greater than 50 using continue. Okay, so we covered the range loop for I in range 1 through 11. Let's just say print I. Check this. So that covers 1 through 10. Write a loop that prints the squares of numbers from 1 through 10, but skips squares greater than 50 using continue. So we could say, let's just do the square operator. And then the math operator in Python built into the language is the double asterisk sign. So this is the square. And then we could say if, actually maybe we could just assign that to, I'm just going to say call it square equals this. And then we could just say if square is greater than 50, continue. And if we can just print then, print square. So what I think this will do, this will break. So we're going to loop through all of those values, and then if the square is greater than 50, it'll skip this. It's kind of like an if else. There we go. Okay, so prompt a user to enter a password until they type secret. Okay, so we could just say user variable equals input, enter the password. And I think we could say while user var does not equal password. All right, let's think of this. How do we do this? We want this to keep going. Let's see, how could we do this? I'm almost tempted to make this into a function, I think. Def in function. We're going to input a string. I know this is we haven't gotten into functions yet, but I can't think of a way how to do this. This might be a bad way to do this too. Enter a prompt to enter until I know we need, sorry guys, let's try and figure this one out. Prompt the user to enter a password until they type secret. All right, so let's just go back to the basics. This is where our theory lecture will get a little bit harder each day. So I'm just going to try this. I don't think this is right. Well, it kind of worked. I think it's kind of hacky, but so I'm just kind of cleaning this up a little bit. Okay, enter the password. This is just wrong passwords, and then if it's type in password, boom, it breaks. So we're kind of defining the same thing twice. Let's just ask AI. So if we go here, I'm just gonna Google this. Say Python. Rather than seeing if it takes forever, let's just go to AI mode. Looks like it's said. I am kind of curious to say better way to write it. It's kind of neat that AI is built into Google these days. Here we go. So this is the better way to do it. So using a break. Okay, so we would say while true. I'm sorry guys. So I'm just gonna do this up here. While true, if username equals password colon break. There's something. Okay, so this is a better way to write this. Boom, you did it. Okay, so this is what I was looking for. I knew something didn't quite feel right. So here we go. So while true loop, and then we kind of continuously ask for the user input. If the user input equals password, then we break. So pretty simple. Okay, we got that one done. So thanks for following along, guys. I think these theory lectures are going to get a little tougher, but it's actually a good refresher. So I will see you guys on the next one. Thanks for following along.